Yeah. Okay, in the meantime, if anyone has any question, do let me know, okay? If you want anything specific to be discussed, do let me know. Otherwise, we will solve a few of the questions here. So, yeah, good evening, everyone. I'm Dipannita, your TA for this interaction session, and welcome to the second interaction session of Fundamentals of Electrical Engineering. So, the first question that we'll be solving today is given here. So, let me take the pen. Yeah. So you have been given a circuit as shown here. These two are the DC voltage batteries connected across the resistance. What you have to find out is we have to find the power absorbed in this 1 ohm resistor. That is, in this resistor, how much power is getting absorbed. Anyone wants to suggest like how we can approach this? Anyone like among the anyone can unmute and speak up. Would you like to suggest how we will go ahead with this problem? Anyone? No? Okay, maybe at the start I will just do one problem right away, and then from the next people can speak up. Right? So, all of you have read in the. I hope you have gone through the lectures, and okay, somebody is still coming in. Let me just admit them. I got to figure out how to do this auto admitting thing. Okay, so, huh. So you guys know the Kirchhoff. This You have gone through the lectures and you have been taught the KVL and KCL, right? Kirchhoff's current law and Kirchhoff's voltage law. So let me admit it. So guys, please do admit in do join in time. Otherwise, it will be difficult to go back and forth and try and admit everyone. Do join in time. So yeah. So I'll be admitting till 7:10. Beyond that, I will have to start, with the flow of the problems. Please do join in time. This is for everyone. So let's assume there is current I flowing through this branch. Okay. So let this be I2 and I3. By Kirchhoff's current law, we know I equal to I2 plus I3, right? Everyone agrees with this? Everyone can follow this? I'll open the Jamboard. Yeah. So I'll just open one of the Jamboard here. Okay. So we'll be solving in this board and looking through questions from here. Okay. So let me zoom this. Okay. So by using KCL, we know I is equal to I2 plus I3, right? Let's just write, okay, since this is I. So now we will apply KVL across this particular loop, right? So if we apply KVL across this loop, it will be 10 minus, since we are moving through this way, here I is moving in the same direction with, we are moving in the same direction as that of the flow of the current I. So it will be 2 into I, then sorry, let's move through this particular loop, right? We are applying KCL across this bigger outer loop. So it will be minus I3 times, this is 1 ohm, right? The resistance here is 1 ohm. I hope everyone can see this. This is 1 ohm. So minus I3 1 into 1 will be equal to 0, because current, like if we apply KCL across this outer loop, we get like summation of all the uh, power in the entire circuit. Because of the conservation of power, it comes out to be 0. So it is 10 is 10 minus 2I will be equal to I3. Now next, if we apply across this particular loop, it will be uh, guys, please do join in time, otherwise it will be difficult to move through the lectures if you keep joining in your own time. So okay, so yeah, now when we apply KVL across this smaller loop, it will be 10 minus 2I. Then we come across this resistor, that is equal to 2I2 plus 10 equal to 0, right? So this will be equal to 20 minus 2I minus 2I2 equal to 0. Now if you solve this equation and this equation, we can get the value of I1, I2 and I3. If we get I3, we can determine how much power is absorbed in this 1 ohm resistor. So let's substitute these values in each of this. So since we have to calculate I3, we will keep I3 and substitute the rest. For example, in this equation, let me change the color. So in this equation, we will substitute the value of I. So it will be 10 minus 2 into I2 minus 2 into I3 will be equal to I3, right? Now we can write I2 in terms of I3. So this will go like it will be 10 minus 3I3. So now when we substitute this value of I2 in here and I in here, this entire equation will be in terms of I3. So can you guys quickly solve what is the value of I3 and let me know? I hope you have got the feel of it. So I will keep this circuit open. I have told you how to solve it. Can you quickly solve it and let me know? So can you tell me what is the value of I3 here? Anyone can try it out. See, there are several approaches you can go through this, like tackle this problem, right? Suppose if you simply, instead of taking individual currents across this branch, you can simply take one current here, I. If I1 current flows through here, what will be the current flowing through here? It will be I minus I1, right? If we are to say that KCL is valid in this node, so the current through this branch will be the total current, incoming current minus whatever is outgoing, that is I2, right? So we can tackle the problem in that way also. There are several ways you can do this problem. You can whatever seems easy to you, you can go ahead and try it out, right? So anyone wants to say what is the value of I3? Are you able to calculate it? Can anyone unmute and answer? Let me check the chat box. I3, I2. So yeah, Amit has answered. Mansi, it's I do not understand. Like the value of I3. Yes, I wanted the value of I3. So if you calculate it properly, the value of I3 will be equal to 0. The value of I3 comes out to be 0. Intuitively, if you look into this circuit, there is a 10-volt battery that is connected across a 2 ohm resistance, right? Similarly, in this branch itself, we have a 2 ohm resistance that a 10-volt battery is connected across it. So basically the voltage drop, like whatever the current is coming out of here, is going through it, and no current is going through this particular branch. So here through this 1 ohm resistance no current is flowing, hence power output is will be equal to I3 into 10. It is V into power is equal to I into V, right? Here, or it can be written as I square R, right? So here I3 is 0, resistance 1. So the total power that flows that is absorbed by this 1 ohm resistance will be 0. Since in the option D, 0 is nowhere in other option, the answer will be option D, none of the above, right? Guys, please do join in time. Yes, Amit, you are right. It is like I3 will be equal to 0 ampere. If anyone has any problem with this question, you can speak up now, or we can move to the next question. Everyone is able to solve this. Please respond with a yes or no.
Yes, ma'am.
Okay, then we'll move to the next problem. So the next problem, you have been given a circuit where a battery is connected across a series resistance, and it is connected across a load with voltage V. The voltage across the load is V, and the load is a non-linear load. Like it not only consists of resistance but might have inductance or capacitance or other like non-linear elements. So the load, like the VI characteristic equation of this load is given by 6I V square plus V. Now it is also mentioned that the current that the load can draw maximum is 15 ampere. So you have to calculate the current I, this particular current that is getting delivered by this battery. Okay, so let's move ahead with this. So see, most all this question, when you see a loop circuit that is connected in form of a loop, the best way to apply is either KCL or KVL. Here we can apply KVL across this loop in order to compute the current, the load current, etc. So first equation that we are given is 6I equal to V square plus V, right? Then when we apply KVL across this loop, since current I is flowing through it, so let's using KVL, we get the equation 20 minus I is the current, resistance is 1 ohm, and the load voltage is given as V. Since we do not know the volt, we will write it in terms of V, right? We do not know the resistance or inductance or anything about this load, but the voltage across the load is given as V. So we can write it V is equal to 0, right? So we have to determine the current I. So let us substitute the voltage in this equation. So voltage from this equation can be determined V equal to 20 minus I, right? Now when we substitute to this equation, the above equation, what we will get? 6I will be equal to V square is 20 minus I whole square plus 20 minus I, right? Now this is one single equation. You can calculate I from this equation. So can you guys quickly calculate I and let me know what is the answer? So let me see if anyone is yet to be admitted. Okay. So yeah, please calculate the value of I. You can unmute and speak up. Like looking into the chat would be difficult for me every time. So you can unmute and speak up. So what will it be? 6I will be equal to 20 square is 400 minus 40I plus I square. Sorry. Yeah. I square plus 20 minus I, right? If we shift all of it in one side, it will be I square, uh, 40I minus I is 41I, and if we bring the 6I this side, it will be 47I, right? Plus 420. Now it is a simple quadratic equation. You can calculate I. So it is minus b plus minus root over b square is 47 square minus 4 AC. That means 4 into 420 by 2a. Here a is 1. So let me take the calculator. Yeah, 47 square minus 4 into 420. Yeah, 529. So I'll just write it here. I is equal to 47 plus minus. Under the square root, this value comes out to be 4. What is it? 420. 529. Sorry, this is 529. So square root of 529 is 23. So 23 by 2. So it can be either 47 plus 23 by 2 or 47 minus 23 by 2. So let me know which will be the correct answer and why. So it will be either 35 or 12. So it is pretty visible from the answer that 12 is given. But why is 35 the wrong answer? Can anyone tell me? Let me see. Someone has must have put something in the chat. Let's admit everyone. Yeah. Can anyone just suggest why that 35 ampere, I guess, is the wrong answer? Can anyone let me know? Yes, exactly. You're right. So it is already given in the question that the maximum current that the load can draw is 15 ampere. Since 35 is exceeding that 15 ampere limit, so the correct answer will be, the acceptable answer will be 12 ampere, which is option C. Everyone could follow this one? Can we move to the next one? If anyone has any question, you can ask right away right now, or we move to the next one. Okay? Okay. So I'm guessing someone is there. Let me admit it. Okay. Sorry. Okay. Let's look into the next question. A circuit is given to you. You have to find this value of this unknown resistance. Do anyone want to suggest like how we can proceed with this problem? See, most of this most of the problems will be solved by like KCL or KVL, or calculating equivalent resistance that you have been like taught in the lectures. So anyone wants to try? We can apply KCL across this node, right? Let's say current I is coming through here, 2 ampere is going through here. Let's consider this the I dash. So using KCL, we know I will be equal to 2 plus I dash, right? So basically I dash is I minus 2. So we can simply replace this I dash by I minus 2, right?
10 ampere.
Sorry. So now you can apply KVL across this loop and you can calculate I, right? So it is 50 minus 5I minus 5 into I minus 2 will be equal to 0. So 50 minus, this is 5I, this is another 5I, so it will be 10I. This will add up and be, sorry, let me just check. Yeah. So this is 10 will be equal to 0. So I will be equal to 6 ampere. So 6 ampere current is flowing like across this. 2 ampere is going there and 4 ampere is coming here, right? Now you can apply KVL across this bigger loop to calculate R, right? So if we apply KVL across the bigger loop, it will be 50 minus 6 into 5 minus 2 into R will be equal to 0. So R comes up to be 50 minus 30 by 2. That is 10 ohm. It's pretty straightforward. I hope everyone is okay with it. If not, you can ask. Everything okay with everyone? Then we can move to the next question.
Yes, ma'am.
Yeah. So, for this particular question, what you have been asked is you have to find the potential difference across this resistor. So, the rule of KVL applies in a loop such that the starting point of the loop and the ending point of the loop itself means if you start at a point, you have to come back and end at a particular point. So in this particular loop, we can apply KVL, right? But what about here? Like if we consider this point to be as A, this, can we apply a loop across this resistance? Can we apply KVL? Anyone wants to respond? So let's say we have started from here, we have moved through here. We cannot come back to this particular point, right? So the KVL can be applied only across a loop. So we have a current flowing through this circuit, a current flowing through this circuit maybe, but the current here will not be flowing because suppose you take this point, let's consider this point as B. Since there is no element connected across this point is also B. This point is B. It is connected across a 5-volt battery. So this cannot be possible, right? So the portion across this, the current flowing across this will be equal to 0. That is, it is almost as if it is not present. Since no current is flowing through it, the voltage difference across this resistance will be 0. Right? Everyone clear on this? Yeah. So if anyone has any question, you can ask, or we can move to the next question.
Ma'am, please repeat once more.
Yeah. So let's just say, like, the rule of KVL. Like, KVL can be applied across the loop. There is a conservation of energy across the, like, the power is conserved in a loop, right? So loop means when you start at a single point, you have to like cross through all the elements in each branch and arrived at that particular point, right? But just consider this particular branch from A to B. So if you start from A, if you move through the resistor, the voltage source, you cannot come back at B. This is not a loop. Like, here it ends. This point is also B, this point is also B, this point extends. Since there is no resistance or any other elements, any other parameters in between this line, so this entire point is the node B. Now this is connected across a 5-volt supply. Now this particular same point B is again connected to a 6-volt supply. It cannot be possible, right? Do you get
Yes,
it?
ma'am. Got it, ma'am. Got it,
Yeah.
got it, ma'am.
So no current will actually be flowing through this branch. The current flowing through this, like, current cannot flow through this branch. Otherwise, the laws itself will fail. So the current through this branch is zero. Since current is zero, voltage is what? I into R. So current is zero. So irrespective of the resistance, the voltage will always be zero.
Got it, ma'am. Thank you.
Yeah. So let me see if anyone is there. Yeah. Guys, please, just a request, please do join in time, otherwise it will be very difficult to keep allowing everyone throughout the class. Try to join in time, it will be good for you. So I hope this is clear to everyone. Then we'll move to the next question. In this particular question, a circuit is given and you have to calculate uh, how much power is delivered or absorbed on this dependent voltage source. Dependent voltage source means this a particular source depends on a certain parameter in some other branch. In this case, it depends on I1, which is the current in this particular branch. So Vs will be equal to 2 into 4, that is 8 ampere, right? Now you can apply KCL or KVL in order to compute. Like, for power delivered, what do you need? You already have the voltage, you need to find the current across this loop, right? So 4 ampere current is flowing through this loop, flowing from this branch. Now using KCL at node A, you can get, let's consider this to be I1, this to be I2. Then using KCL, I1 plus I2 equal to 4 ampere. Or uh, let's replace I2. Yeah, because we need to calculate I1, we will write I2 in terms of I1, 4 minus I1. So now let us apply KVL across this particular loop. So it is V minus Vs. Then this 5-volt source come, so it is 5 volt. Then I2 current is flowing through this particular branch, right? So it is I2 into 1 ohm resistance. The summation of this will be equal to 0. Now Vs, we know it is 8 volt. This is 5. Sorry, you don't need to write the unit here. So it's 5. So, and this is I2. I2 you can write in terms of I1. So it is 4 minus I1. So you can easily compute I1, right? This will be minus 8 plus 5 minus 4 plus I1 equal to 0. So I1 will be equal to 4 plus 8, 12 minus 5, 7. So the current flowing through this branch is 7 ampere. So you guys can compute power here, right? Power is V into I. So 8 into 7 is 56. Now, whether it is delivering power or absorbing power. Now, current is coming out of the positive terminal. So, it should be delivering power. So, the correct option will be B, 56 watt, and it is delivering the power. I hope it is clear to everyone. If
Yes,
yes,
ma'am.
yeah. Okay. No one is there for admitting, so I'll move to the next question. Now, the sixth question is for this particular circuit, what is the value of k is dimensionless. What is the value of k, so that there will be no solution existing for this particular circuit? So how will we approach this problem? Most of the problems here we will either use KCL or KVL, right? So let's apply KCL across this node. So we know this current 3 ampere is flowing through this branch, so this is 3. So let us consider this to be I1, this to be I2. Using KCL, 3 is equal to I1 plus I2. Now we have the voltage across this particular node. Let's consider this to be the node A. So across this node, and let's consider this to be B. So the current, this I2, since resistance is given, the relation between V and I2 will be voltage is equal to 2 into I2, right? So if we write I2 in terms of V, it will be V by 2. So we simply replace I2 by V by 2, right? So let's write it as V by 2. Now current across this resistor will be the voltage difference across this resistor, that is VAB by 4, right? So the node B, the voltage is KVB, right? So the voltage AB will be equal to voltage at A minus voltage at B. So voltage at A is given as V. Since this point is common, this is the neutral. So voltage at A is given by V. Voltage at B is given by KV. So minus KV by, what is the resistance? 4 ohm. 4. So if we simplify this, it is V minus KV plus, we take the LCM, right? So it will be 2V is equal to 3. So let's simplify this. It is 3V minus KV equal to 12. So it is 3 minus K times V equal to 12. Now can you suggest what will be the value of K when this will have no solution? That means this equation will render invalid. What could be the only possible value of K for which this equation will be invalid? Can anyone speak up?
0.
No, see, look, if suppose let's assume if K is equal to 0, what will be the equation? 3 minus 0 times V equal to 12. That is, this will be in bracket, right? So it will be 3V equal to 12. V will have a certain value, that is 4.
Ma'am.
Only possible solution here, just think on
3 will be
3. 3.
exactly. So if K is 3, what will it be? 3 minus 3 times V equal to 12. So this side will be 0. 0 cannot be equal to 12, right? So only when K is equal to 3, this entire equation becomes invalid. So the correct option is D, 3. I hope it's clear to everyone. If not, you can ask now. In the meantime, I'll look if anyone wants to join. Yeah. It's clear to everyone? Okay. Then we move to the next question. So this is kind of a conceptual question. You have been asked like if n is the total number of nodes, b is the total number of branches, and l is the number of independent KVL loops in the network, then what is the relation between them?
A,
So,
ma'am.
sorry, yeah, you're right. It's A because you have been taught in the lecture the total number of KVL equation that can be formed when there are b number of branches, n number of nodes, and so it will be, if b number of branches are present, n number of nodes, the total number of kvl equation is there. So here number of kvl equation is denoted by l. So if we calculate b, it will be l plus b minus 1. This is like pretty straightforward. I hope everyone is clear on this one, because it has been like taught in the lecture by professor. So next what we will look into is equivalent resistance. So this is uh, one of the questions given in the exercise. So before we start this off, I hope everyone is okay with star and delta conversion. There are two things you should know before attempting this problem. One is, in case anyone is not familiar, anyone is very new to solving circuits, let us just revise. If two resistors are connected, suppose in parallel, okay, so I'm sorry, my circuit is very bad. So let's consider this to be R1, let's consider this to be R2. What is R equivalent across A and B? Can anyone just tell me?
1 by R1 plus 1 by R2
Right,
plus 1
this
by
is
R
1 by
equivalent.
R equivalent is 1 by R1 plus 1 by R2.
So it's going to be R1 R2 by R1 plus R2.
Right, if we just compute this, it will be R1 R2 by R1 plus R2. This you should remember because it comes pretty in handy, like if you just remember this. Now the conversion between star and delta. So a delta network is that, let me just check if anyone is there in the waiting room, because like, yeah, guys, please join in time, just a gentle reminder. So yeah, so a delta circuit is this kind of a circuit which is in the shape of a delta. So let's say this is RA, RB, and RC. Now its equivalent star network is given. Suppose this is one point, this is the next, this is the third point. So its equivalent star network relation is given in this way. Let me, like, sorry, let me get the eraser. Yeah, let's consider this R1, R2. This green color inside one is the star equivalent star network. Star because it is in the shape of a so-called Y shape. Okay, delta is in this shape. Now the conversion relation between these two you have been taught in the lecture, but I'm still revisiting this because it will be handy in this problem which we'll be solving. So the trick to remember is, when if you're converting from delta to star, that is from this red color circuit to this green color circuit you are converting. So for example, we are calculating this particular resistance R1. I hope it's visible, otherwise I can just highlight it. uh, so yeah, we are computing this particular value R1. Okay, for that the trick is to, from delta to star, when we will be converting, it will be the multiplication of the two adjacent branch, that is RC RB. R1 is between RB and RC, right? It will be between RB and RC, multiplication of those two branch and summation of all the three branches, that is RA plus RB plus RC. Now this denominator will be same in each, for each of the resistance R1, R2, and R3. R2 and R3. Similarly, denominator is remaining constant in all the three. RA plus RB plus RC. RA plus RB plus RC. Whereas the numerator for R2 will be, R2 is between the branch RA and RC. So it will be RA into RC. The R3 is between RA and RB. So in the numerator it will be RA and RB. So You don't really need to remember these formulas. If you are to suppose convert between this star, this delta circuit to its equivalent star, what you can do is just take the multiplication of the two adjacent branches and divide by summation of all the branches. This is the trick to remember from delta to star. Now in case of the reverse, if the star network is given and you have to convert it to delta, let me just admit all the students. I can hear a pretty number of noises. Yeah, for this kind of conversion, so now I will change the pen color. Yeah, now from star to delta, so you have been suppose given this R1, you have to calculate RA, RB and RC. So what will be RA? So in case of star to delta conversion, the numerator of all the three will be same. Okay, it is cyclic multiplication of the two branches. Suppose R1 R2 plus R3, sorry, R2 R3 and R3 R1. It will be same here also. It will be same here also. This numerator remains the same. However, the denominator, if you are to calculate, suppose this RA branch, let me use the highlighter. Yeah, if you are to calculate this RA branch in the denominator, you will have to divide it with the branch that is just opposite to it. So in this branch, the opposite to it is this R1, right? So we will have to divide it with the value of R1 resistance. RB, opposite to RB, which branch is there? Can anyone speak up? What will it divide it by?
R2.
R2, right? Similarly here R3. This is the trick to remember between star and delta conversion. So now we will proceed with this problem. Let's look. So let me use the highlighter. So these the two highlighted like R values, these branches. Can you comment on the relation between these two? Are they connected in series? Are they connected in parallel? Are they connected some other way? Can you comment? Go ahead. Yeah, someone I think is responding, but in a very faded voice. So these two branches are connected. Right. These two are connected in series. So we can simply remove this and write it with an equivalent resistance 2R. Right? Now can you comment this 2R and this R? They have the same end point, right? Let us consider this X and let us consider this Y. So these two are in parallel with each other, right? So if you are to simplify this circuit, let us redraw it. So yeah, let's simplify one branch at a time. Now this particular branch is this X and Y branch. So what will be the equivalent resistance across this X and Y? Can you please quickly respond? Meanwhile, I'll draw the rest of the circuit. So this is B.
2R by 3.
Right. Since these two are in parallel, this will be 2R by 3. Now rest of it is all R. Now to simplify this circuit, this looks like kind of a delta kind of a circuit. Whenever a complicated circuit is given in and it kind of looks like delta, you convert it to star and check if it can be simplified, or if it is given in form of a star, you convert it to delta and check if it can be simplified. So now we can apply delta to star connection, right? So let's convert this one. This is the point, let's say A, this is C and this is Y. So we can convert an equivalent, we can get an equivalent star connection, right? So can you tell me what will be the values of this resistance? I'll redraw the circuit. This is A, this will be its equivalent star, So this is the point Y, this is the point C, and rest of the circuit remains the same. Okay, so 2R/3, this is R, this is another delta kind of a circuit. Let's keep it as it is for now, and this is the point B. So we have simply converted the delta circuit that was here into its equivalent star. Now can anyone tell me what will be the value of this R? In the meanwhile, admit whoever is here. Okay, maybe let's discuss about the first conversion, then you can comment on the second conversion, right? So,
3R.
right. Sorry. No. Uh, so, the delta to star conversion, what did I tell you? It will be the multiplication of these two adjacent circuits, adjacent branches, right? So, let me take the highlighter. Yeah. So, these two are the adjacent branch to this particular branch, right? If you are to convert it to from the delta to the star connection, so it will be multiplication of the two adjacent branch, that is R and R, multiplied by summation of all the three branches, that is R plus R plus R. So it will be R square by 3R,
R
right?
by 3.
So it is R by 3. So this is R by 3. Since all the resistance are equal, they all will be similar in magnitude, right? This will also be R into R by 3R. So it will be R by 3 by R by 3 by R by 3. This is fine. Now let's consider this point. This is point C, right? Okay. Now let this point be, this is already there, okay, X. Now we will convert this delta into star, this CBX, this circuit we will convert it to star. Let the rest of the circuit remain the same. Be very careful in doing this kind of circuit because you tend to make mistakes. So this part of the circuit is same. These are all R by 3, R by 3. This point is the C point. This is, let's say, N point. This point is A, and this is Y. Now, this X to Y branch will remain the same. Only thing that we will convert is this, these three, right? We will convert it with an equivalent star resistance. So, you see across, let's consider this point to be O. So, between C, X and B, we are converting from delta to star. So, the star network will be like this, this and this. This particular branch, it is as it is between X and Y. Let me keep it in red itself. Only thing we are changing is CBX. Oh, sorry. Um, yeah. So what will be the resistance across, let's say, C to O? This will again be R by 3, because like I showed in the previous one, it will be R into R by R plus R plus R. So R by 3 by R by 3. So now this has been simplified into, more or less it has been simplified. Now we will figure out which are parallel and which are in series. Let me just copy it to the next slide so that we can write it. So let's open up a new slide here. I'll copy it here. Okay. So now we have to simplify this green colored circuit. Okay. Uh, so yeah. So we have to find the equivalent resistance between A and B, right? So this is A. So there is one R by 3 resistance across A to N. Now between this N, let's draw it properly and then we will calculate. There is, so this R by 3, this particular resistance and this particular cell resistance and this particular resistance, they are all in series because nowhere there is another connection with another, let's say another branch that connects to any other node. Like these three resistance are connected in series. You guys agree with me or not?
Yes, ma'am.
So this is R by 3, this is 2R by 3, and this is R by 3 again. Now this between N and between this O, this particular resistance and this particular resistance are connected in series. So it is R by 3 plus R by 3, 2R by 3. Right? And finally, between O and B, there is another resistance R by 3 which is connected. Now the summation of this is 4R by 3. So basically now the circuit can be simplified to R by 3, 2R by 3 in parallel with 4R by 3, and this is in series with R by 3. So let's move sequentially now. So what will be the, so if we just convert this parallel into series, like equivalent parallel between this point N and this point is, this point was O. So between N and O, we calculate the equivalent resistance. So it will be, could you
4R
calculate?
by 9. 4R by 9.
Right, 4R by 9. Now all these resistance are connected in series. So what will be the final equivalent circuit between RAB? The summation of these three. What is the summation of these three?
10R by 9.
Right,
10R by 9.
10R by 9. Now if R in the question is probably given as 30 ohm, so you can easily calculate, this comes out to be 33.33 ohm. This is one of the numerical given in the uh, like the problem sheet that sir has shared with us. So anyone has any problem understanding this, please let me know. I am okay with explaining. Is there any? Okay, that you guys decide about WhatsApp group, that I do not know. If you have any queries, you can write via mail or whatever is convenience for you. uh, so anyone has any trouble understanding this, please do let me know, otherwise we can yet solve another problem. Everyone okay with this one? Let me look through the chat if anyone has any queries. Series. Okay. I see there is no question in the chat. So I hope everyone is getting it. Yes? Okay. Then let's move to another question. So here you have to determine this voltage V and the current across this branch I. See, you can use KVL and calculate the current I and the voltage V, or what you can do, you can use the current divider rule. Since we have applied KVL in a lot many other problems that we have discussed, so let me just solve this using current divider rule. Now current divider rule states that suppose if there are two parallel branches, like, so let's say there is a voltage V connected across this is R1 and this is R2, and this is the total current I. The branch in the current across this branch and this branch will be, so I2 will be equal to, it gets divided, the higher the resistance is, the lower the current is. So it is R2 by summation of R1 plus R2 times the total current I. In case of voltage, it is the reverse, but in case of current, in case of voltage, it is in a ratio of their resistances of this each branch, and in case of current, it is opposite to that. So R2 is the other. This is R2. R2 is the resistance of the other branch. So you can use the same in here. Like let's say this is node A, this is node B. So these two resistance are in series with each other, and this resistance, the summation of these two resistance is in turn parallel with this 5 ohm resistance, right? So we simplify the circuit in this way. So let us say this is 10 ohm resistance, this is the voltage across it, this is the 5 ohm resistance, and the other branch is 10 plus 5, 15 ohm, right? So this is the current given here I. Since like the current flows through the entire branch I, we can simply take I in this 15 ohm branch, ohm resistance branch, and let us consider this let us consider this to be I dash, and this to be I double dash. So you are given the resistance across this you are given the voltage across this resistance, right? So what you can do is calculate the current flowing through this branch, since resistance is given and you know the voltage. So this I double dash will be flowing through the entire branch, right? So I double dash will be V by R, right? V is given 20 and this is 10, 2 ampere current is flowing through it. So when the total current that is flowing through this one is 2 ampere, and it is getting divided into two branch. Now using this current divider rule that I have mentioned here, you can calculate I, right? I will be equal to 5 ohm, that is the resistance across the other branch, divided by the summation of the two resistance of the two branches. This is 5 plus 15 into I, the total I that we got here is 2 ampere. So it will be 2. 5 by 20 into 2, it is zero point 0.5 ampere. So the current across this particular branch here is zero point 0.5 ampere. Now to calculate this voltage, it will be a summation of like you can use KVL, or you can simply calculate the voltage drop across each of these resistors. So just simply by applying KVL, you can get V will be equal to the it is like given here 20 volt plus 6 into 2. Voltage across this resistor will be 6 into 2, 6 ohm into 2 ampere, right? So it is be plus 12 volt. Now across A and R, since you know the current and you know the resistance, so the voltage drop across these two will be so current is given as 0.5 into 15, that is 7.5, right? The voltage across this VAR will be 7.5. So 20 plus 12 plus 7.5. So it will be 20, 30, 32, 32, 39.5. 39.5 volt. Everyone clear on this one? Anyone has any questions? Yes, somebody wants to ask anything? Yes, Amit, you're right. Do you want to solve one more questions before leaving? It's almost time, but we have started anyway 5 minutes late. So do you want to solve another problem before leaving? Yes or no? Let's, okay, somebody is coming now. It's okay. Let's then solve this 10th question. So it is given the current across this R, small r, is 0. So you since this condition is given, you have to like solve the value of R and the current I. So let's draw this circuit. Let's simplify the circuit. This is the node B, this is the node C. So 20 volt, 2.6 ohm, it is given, right? Now let's draw it like properly. So this is one of the resistance given, this is another, it is connected via C. So yeah, now another branch, this small, which has a resistance of small r, it is given that no current is flowing through it. So since no current is flowing through it, we can very well, this acts as an open circuit, we can very well remove this branch, right? So let's get rid of this branch. Then this is given as 1 ohm, this is given as 2 ohm, this is 4, and this is R. This is unknown. Now if we like those who are very new to electrical engineering, you probably may not have come across this, but those who are in their second or third year, you might know the Wheatstone bridge principle, right? This bridge is kind of said to be balanced if the ratio of the resistance across the two branches are same. That is to say, like the from the Wheatstone bridge principle, we get this. Let me use the highlighter. Yeah, this multiplied by this is equal to the other two multiplication of other resistance across the other two branch. So it will be 1 into R will be equal to 4 into 2. So R will be equal to 8 ohm. So we get the value of R equal to 8 ohm. Now to compute I, that is the current through this branch, we can either use like we can use KCL and KVL to simply compute the current through this branch. We can compute the total current and find, or you can use the current divider rule to find the current through this branch. Now let's since we have discussed about the current divided rule in the previous question, let's just do it that way. So let's find the equivalent resistance between B and C. So these 1 ohm, this 1 ohm and this 2 ohm resistance are connected in series, right? So it will be 3 ohm, and this 4 ohm and 8 now calculated 8 ohm resistance are connected in series. So 4 plus 8 is 12. These two are connected in turn, these two are connected in parallel with the 2.6 ohm resistance. So let's calculate the equivalent resistance across B and C. So equivalent resistance across B and C will be 3 into 12 by 3 plus 12, that is 15. So 5, so 12 by 5. So this comes out to be 2.4. Now the circuit is simple. These two resistors are connected in series, so it is 2.6 and 2.4, and there is a 12-volt battery connected across it. So the current that is flowing through flowing out of the battery will be 12 by 2.4 plus 2.6, that comes out to be 5. So 2.4, the battery is 20 volts, sorry, the battery is 20 volts, so it is 20 by 5, so it is 4 ampere. Now 4 ampere current is flowing out of the battery. Now in the current that will flow, that is I, so let me denote this by I1. This is I1. Now this I will be, using current divider rule, we can get the resistance across the other branch, that is 3 ohm, by the total resistance, that is 3 plus 12, 15 ohm, times the total current, here it is 4 ampere. So I will be equal to 3 by 15 times 4, it is 4 by 5, that is 0.8 ampere. So the total current flowing through this R ohm resistance is 0.8 ampere, and here R is equal to 8. I hope everyone is clear with it. Is everyone clear? Yeah, right.
Ma'am, can you explain that?
Yeah, which part?
I equal to 0.8 ampere. How?
Okay, that part. So, you know, you have been taught the current divider rule in case of suppose there is a resistance in parallel with another resistance R. This is R1, this is R2. And if I amount of current is flowing through it. So you can use KCL and solve this, or you can use like the current divider rule. Suppose this is I2 and this is I1. So the current across, suppose let us say R1 is much greater than not let's say much greater, just greater than R2. So the higher the resistance will be, the lesser the current it will flow through the circuit. You can prove this using KCL also. So the current divider rule, by using current divider rule, you can get the current across the branch R1 will be equal to the resistance across this opposite branch R2 by summation of the two resistance R1 plus R2, if this is the total current. It will be in the inverse ratio of their resistance. It has been discussed in the lecture. Like you can prove this using KCL. So this is easy way of determining, instead of writing equations of KCL, this is easy way of determining the current across a branch when two resistances are connected in parallel. So in this particular case, this 1 ohm, like let me use the highlighter. Uh, so this 1 and 2 ohm resistance are connected in series, which is given by this 3 ohm, and this 4 and 8 ohm resistance are connected in series, which is given by 12 ohm. Now this current which is flowing through the second branch, which has like this 12 this is this 12 ohm resistance in total, we have to find the current I across this particular branch. So the current across this particular branch I will be equal to in the inverse ratio of the resistance, right? So the resistance in other branch is 3 divided by the total summation R1 plus R2 as given here. So 3 plus 12, 15. So 15, sorry. Yeah. And this is the total current I. If you have any confusion with this, you can also use KCL. Do you get it? Could you respond if you got this one, or you can use KCL? I'll show you like how you can solve using KCL. This is called the current divider rule. Since the total current entering through this node is 4 ampere, it will get distributed into some current here and some current here, right? Could you please respond? Okay. Okay. So I hope there is no other question. If you have any other questions, you can ask, or we can like get done for the day, because the time is, I guess, up. So, do you have any questions in from the lecture, or anything that we have solved now, or anything the previous TA has solved? If you have anything to ask at all, we can discuss, or we can call it a day. Let me check if there are any messages in chat. No. Okay, then thank you all for coming. If you have any questions, you can like, so this is my mail ID. You can mail me if you have any questions, or we can discuss it in the next interaction session. I would prefer to discuss it live, because it might so happen that you have the same doubt as your friends and it will get clear. If you have any feedback for me, you can suggest, like if I'm going too fast, if something is not clear, if you need more examples, you can even talk about it. Otherwise, okay, thank you all for coming. We'll meet again. Let me stop the recording.